The handout I gave out last time. Okay, let's do a quick poll, and this way we can I can get you to understand the handout I gave. So this is based on the handout. Let's do a. So we'll do a multiple choice question. Okay, so first question is, which principle would you apply to solve this problem? Why don't you use your iClicker? I just started a poll. Use your iClicker. Anybody wants the handout? It's actually posted on Blackboard. The 10 lb block has a speed of 4 feet per second when the force is 8t square. Determine the velocity of the block when the time is 2 seconds. So given the speed when the time is 0. Okay, you guys done polling? Okay, so if you asked velocity is a function of time, then it's number 3. It should be A or B, right? If there's an external force, then you're stuck with 3B. Sorry, 3A, right? Not 3B, my bad, 3A. So you can change your answer. I've not closed the poll. But this is just a. As few people thought with A and B, but you feel free to change the poll. If you've come late, you can click C. Okay, I'll keep this on. I'll stop it in a bit, but please change it to C. C is the right answer. You can't use anything else in this case. Okay, let's solve this using principle of. Well, before we apply the principle of impulse momentum, let's draw the free body diagram. So the principle of impulse momentum is mv1 plus integral f external dt equals mv2. So the mass is 10 pounds. So 10 divided by 32.2. Initial velocity is 4 plus the net force. In this case, we are doing the principle of impulse momentum along the horizontal direction. So only the horizontal forces will appear here. So the force F is 8t square. The friction force is mu k mg, or 0.2 times 10, and it's a constant, right? So F external is 8t square minus 2 dt, and the time goes from 0 all the way to 2, equals 10 divided by 32.2 times v2, where v2 is unknown. Okay, so that integral is very straightforward. I will not spend time doing that. The answer is 59.8. Okay, yeah, question?
Why can't we use the principle of work energy?
Because principle of work energy is used when you're asked to find force. Oh, sorry, you're told to find velocity as a function of displacement. In this case, you're told to find velocity when the time is 2 seconds. So Vt, think of impulse momentum. Vx, think of work energy or conservation. So that's number 3 here. Okay, any questions? So, okay, so I picked this question from the textbook, obviously, but this is actually the question from. It's not from this chapter. It's not from chapter. Was that 15? It's not from 15. Actually, from 13. It's 13:6. Okay. So in the book, this is solved using equations of motion. And I'll post the solution. I'll post the book solution. So book did it a different way, and I told you earlier that all these questions you can solve using equations of motion. However, this is the shortest way, fastest way of solving the problem. Okay, so you could use equations of motion too. I'll post the book solution later on. Okay, any other questions? Okay, if the supplied force F equals 150 newtons, determine the velocity of the 50 kg block A when it has risen 3 meters, starting from rest. So we're told that velocity is, why don't we first identify the principle? Let me give you the same question as previous. Okay, so use iClicker to poll your answer. Is it A, B, C, or D? The question is this, and you got to identify which principle should be used. Okay, B. Bunch of people have not answered. Okay, please use iClickers to poll your answers. Yeah, stop in like 20 seconds. Okay, so this is the results of the poll. Okay, so since there's only gravity involved in this question, people answered 2A, but I might say that you can actually also solve it using 2B. This is a problem which also can be solved using 2A or 2B because the force F is actually a constant. Now, if I put the force as, let's say, 150 T or T squared, then you will not be able to use 2A to solve it because the force, external force, is not conservative. Okay, so if you answer 2A, 2B for this question, it is the right answer. Okay, the way I could have twisted the question, let me just pull up the question. So this force is constant, that's why 2A and 2B are valid, because all forces are conservative. If I change the question and I put F equals, let's say, 150 times T, or 150 times S, where the force is not conservative, the external force is not conservative, then you cannot solve it using 2A or conservation of energy, because conservation of energy is only valid for conservative forces. So in which case 2B would be the only way to go about solving this. But everybody got it right because you could use either of those two. Okay, so let's solve this using, you have any preference, 2A or 2B? 2A, okay, let's do it with 2A. So 2 is conservation of energy, or T1 plus V1 equals T2 plus V2. Okay, since the block starts from rest, the initial kinetic energy is 0. For the potential, we need to decide a datum. Okay. Let me, actually, I think that if I try to solve this using conservation, it will actually be confusing to many people because what's the potential associated with F? And I did not really define that in the class. So let me not take this route because it's going to be very confusing, right? Because we do not know I've not defined that. So just for that, let me just not do it using 2, but you can most certainly do it with 2. You can treat the force as a conservative force and do it. So let's use principle of work energy, which is 2b. Okay. So again, the initial kinetic energy is 0. The final kinetic energy is half mv2 square. We just have to find the work done by the forces. Okay, in this case, the forces are U due to F, and then there is U due to gravity. Since I want to find the work done due to gravity or force, I need to multiply the force with the displacement. So in this case, I have to start with some sort of a line for the origin so that I can then relate the motion of point B with that of point A. Think of it like you did a kinematics problem, right? Where you found relation between movement of point B and point A. So let's choose this to be the datum. Let's call this YA. This is YB. Let's try to find the length of the cable, the one highlighted in blue. Now, since in this case I have actually 2 cables, one of them is wrapped on B and C, and the other one is wrapped on A and connects to C, one shown in red and one shown in blue. I will not be able to establish a relation between y and y if I just use those 2 variables. I need an intermediate variable because remember, if I told you if there are 2 cables, then you need to define 3 variables. So in this case, I have to define an intermediate length that will be C. So kinematics. Length of the cable BC equals YB, which is the left half part, plus YC plus YC. YC is this part. YC is the part on the left and right of pulley C. So then I can differentiate with respect to time. 0 equals YB dot plus 2YC dot, or in other words, remember that Y dot B is simply delta Y divided by delta T, and I can cancel the delta T. So 0 equals delta YB plus 2 delta YC. I eliminated the d delta T in the denominator because that's common. So that gives me a relation between B and C. I need to find a relation between C and A and then connect A and B. So length of the cable on C and A, the one shown in red, is YA. That's the right side part of A, and the left side part is going to be, what's this going to be? YA minus YC. So differentiate 0 equals ya dot plus, that's going to be 2ya dot minus yc dot. So I can write that by eliminating the delta t in the denominator as 2 delta ya minus delta yc. So let's call this equation as 1, the second one as 2. So from 1 and 2, 2 delta ya equals delta yc, which is minus delta yb divided by 2. So delta, see, we are given a has risen 3 meters. Okay, we know how much a moves. So delta yb is negative 4 delta ya. Okay, so now we can proceed and find, going back to the equation which we were after, number 3. Okay, let's now try to find UF and UMG, and you'll see that UF and UMG actually depend on delta ya yb. So 0 plus UF is, okay, my convention is, well, F is downwards, right? And my convention is downwards is positive, so I would write that as F times delta YB plus mg is downwards and delta ya is downwards. Right? That's the convention. I'm just sticking to the convention. Equals half mv2 square. And now is the time when I actually put in the values. So F is 150. Delta YB is minus 4 delta YA plus mg. Hold on, let me do it in a different way. 150. Okay, delta YB is minus 4 delta YA. But what is delta YA? A has moved upwards. So when my convention is positive, it's downwards. If A moves upwards, it's negative. So minus 4 delta ya, which is negative 3, not positive 3 because A has moved upwards, plus mg, with the value m is 50 times 9.81. Delta y is negative 3 equals half times mass, which is 50 times v2 square. The only unknown is v2. If you solve for v2 from that equation, you should get 3.62 meters per second. Okay, again, let's think where this makes sense. Mg is downwards, but the block A moves upwards, and so the work done is negative. We are getting negative quantity. That's right. For the force, F is downwards. We've seen that when A moves upwards, B is going to move downwards, right? So if B moves downwards and force is downwards, then the work done is going to be F times delta Y, which is positive. And if you look at the math here, is minus times minus going to be positive. So 150 times 12. So that checks out. So in other words, what I'm trying to make a point is that stick to a convention and just follow through with that convention. It's less cumbersome than trying to, juggle values and put the right values in the beginning with the right sign. Sorry, the values should be the right, but the signs you can postpone it, delay till the end. Any questions on this?
So you would have to do it this way. The force giving have like a 150s.
Then it is a well, you have to do it this way no matter what. So if it was 50, 150s or 150t, just use work energy because we have not defined a potential corresponding to F. We have only defined a potential for mg and potential for spring. So if you don't see a spring and force, don't use conservation. Okay, so by the way, this question is not from chapter, well, we use work energy, which is chapter 14 concepts. This is actually a question from chapter 13. It's 1323. Okay, so the book solves this using F equals ma. Again, I want to say that you can solve this problem using F equals ma. What you'll have to do is you have to first solve for the acceleration of the block A using the force, and once you find the acceleration, then you find the velocity by integrating the acceleration or using the velocity acceleration formula, the constant acceleration formula. Okay, so I'll post the solution which the book gives, but this is an alternate way of doing the same problem. Okay, any questions? No? Box falling. This one? Let's do it. Okay, so the 10-pound box falls off the conveyor belt at 5 feet per second. If the coefficient of kinetic friction between the surface along AB is 0.2, determine the distance x when the box falls into the cart. Okay, so if we start thinking of this problem and try to fit this into the formula sheet, we'll see that we're not told to find distance as a function of velocity, nor are we told to find the time as a function of velocity. Right? It doesn't fit 2, it doesn't quite fit 3, at least the way it is set up. Okay? This is one of the problems which is actually involves a mixture of things. So when the block moves from A to B and there's friction, you got to think of it as like a dynamics problem. Okay, that's where you'd use either 2, 3, or 4. But the moment it leaves the point B, it's falling freely under gravity. It's no longer a dynamics problem; it's a kinematics problem, which is chapter 12. So if you think of breaking it up into 2 parts, then you should be able to solve it. So if you think of it backwards, actually you might be in a much better position to ask yourself, what do you need in order to solve this problem? So what I mean by that is, you're going to find x. What do you need to know to find x? X, so the velocity, right? The velocity with which the ball, the block leaves. You actually know the angle it's going to leave. It's actually given by this 3, 4, 5 triangle. So this theta is known. The velocity is unknown. So if we can find the velocity at B, then we can set up the projectile problem and solve for x. Okay, so now our question boils down to finding v at B. You know the velocity at A, right? So if you know the velocity of A at A, and if you want to find the velocity of B, and you know the distance from A to B, let me put that down. If you know the velocity at A, you know the velocity, well, you want to find the velocity at B, and you know the distance from A to B. We call that SAB. . You can find that because you know this and you know the slope. So you know that. What principle would you apply? To B. Yeah, so you're told to find velocity as a function of displacement, and so it boils down because you see V and S or X. It's basically a problem involving either well, it's two, but since there is friction, you no longer can use conservation of energy. If it was frictionless, yes, you could use conservation of energy, but since there's friction, you cannot use conservation, so you got to use 2B. So first, so as I said, divide in two parts. A, motion from A to B. I'm going to use work energy, and B, motion from B to C, use kinematics. Weight of the box is 10 pounds. So let's set up the equations. From A to B, work energy T1 plus U12 equals T2. Initial kinetic energy is half mv1 square plus U12. U12 is the work done. Now, whenever you ask for work done, my recommendation to you is draw a free body diagram, because a free body diagram will show you all the forces, and the work done is by the external forces. So, free body diagram of the block. Mg is theta, and there's friction. So if you like, you can instead write this as mg sine theta, mg cosine theta. The friction force is mu k mg cosine theta, because friction is mu k times n. Write it down. Which is mu k mg cosine theta. Okay, so let's find the work done. Look at the free body diagram. The forces involved are N, Fk, and if you like, you can think of mg, but then you'll have to resolve it. I like to think of this force and this force. I just think of the resolved forces. And the advantage of thinking of the forces which are resolved is that I can clearly see that capital N and mg cosine theta do no work, and they do no work because the block, when it's sliding, cannot move normal to the plane. It can only move parallel to the plane. So N and mg do not do any work. So the only work done is due to Fk, which is mu k mg cosine theta times the distance moved. We'll call that SAB. And what's the sign on this? Is it positive? It's negative, right? The force of friction is upwards, but the displacement is downwards. And when those directions are opposite, it's negative. Okay, so that's the work done by Fk. We also need to find the work done by mg sine theta. So mg sine theta is the force times the displacement, which is again SAB. And the sign is positive because mg sine theta and SAB is in the same direction. equals half mv2 square. So let's sub in values for different things. M is 10 divided by 32.2. V1 is 5 square minus mu k is 0.2. Mg is 10. Cosine theta. You can write cosine theta here. Sine theta. So the way I've defined theta is this angle. So sine theta is going to be the opposite side, which is 3, divided by the hypotenuse, which is 5. So cosine theta is going to be the adjacent side, which is this one, 4, divided by the hypotenuse, which is 5. So cosine theta is 4 divided by 5. The distance SAB you can find it because you know theta. So SAB sine theta is 15. So SAB should be 15 divided by sine theta. Right? SAB is this distance. Sine of that is going to give me the vertical height. And so I just move things around. It's 15, right? So 15 divided by 3/5. Is that wrong? I think it's 25. So 25 plus 10 sine theta is 3/5 times 25 equals half times etc. Okay, the only unknown is V2, which is the velocity at B. So this is V2. V2 equals 27.08 feet per second. We don't need that really. Okay, so now it's a projectile problem. Do you want me to solve it? Why don't you try to solve it yourself? I'll give the final answer. You should try to solve it yourself. That's why I can solve more problems. The answer the book gets is x equals 18.2 feet. Okay. So how will you get x? Well, you know the vertical height, you know it's 30 feet. 30 minus 5, so the distance from B to C in the vertical direction is 25. Right? 30 minus 5. So you've got to find the time it takes to go from B to C. And once you find the time it takes to go from B to C, you can find x because it's simply B cosine theta times the time. So try solving that, see if you get 18.2. Okay, any questions about part A? Okay, so we are left with two questions. You have any preference? There is this question and that question. The block? Okay, let's do this one. What's that? But the question was, do you have a preference on which question I should solve? There's this question.
No, the question from the book, like the one we said.
Oh, which question it is? Let me see. It is 1428. You want to go one with the car? See, how many? 9 minutes. I think I can do both of them. Let's do the car one. It's easier. So determine the maximum constant speed at which the 2000 kg car can travel over the crest of the hill A without leaving the surface of the road. Neglect the size of the car in the calculation. Okay, so the car is traveling at constant speed. V is constant. Okay, so what's the condition for the car to not leave the surface of the hill? The normal force equal to 0 is the condition for leaving the surface. Okay, so if you're asked to find a force, you have no other option but to use the equation of motion. So let's draw a free body diagram at A. mg n Okay, so if you go to number 4 in the handout, that's when you use the equations of motion. We have a bunch of choices now. We can use r theta coordinates, nt coordinates, or Cartesian coordinates. 3 options. Which one should we use? Nt. And the reason why you would use nt is because when you're given the curve y equals f of x, like in this case you're given 20 times 1 minus x square divided by 10,000. That's y equals f of x. Use nt coordinates. So let's draw the nt coordinates here. Ut.
So when you're given a function y and x, then that's
NT. Don't use r theta, because if it's r theta, then the equation would be given as a function of r and theta. Okay. So that's that. Let's write the equation of motion. Since I'm interested in the n direction, I'm going to write Fn equals mass times an. Fn is n, which is negative n now because n is in a direction opposite to un, plus mg equals mv squared divided by rho. You want to find when n is equal to 0. You can cancel off m. So g is 9.81 equals v square, which is the unknown, divided by rho. Yeah, so rho is the formula which is in the book, 1 plus dy dx square 3 by 2. Yeah.
So you say you don't want the car to leave the surface, and it leaves the surface and rho.
Yeah, that's the condition when it just begin to leave the surface. You don't want it, so you don't want n to be just negative. So it's a boundary. You need to find a boundary condition. So as long as the velocity is less than, you should be fine. So rho can be found because you know the equation of the curve. Since I want to solve another problem, let me post the solution in the book. Give you the final answer. You should solve for v and then check your answers. Okay. So the book gets v equals 49.5 meters per second. Okay, and this is a question from chapter 13. It's 1374. Okay. Okay, so I still have 5 minutes. Let's do the last problem. A ballistic pendulum consists of a 4 kg wooden block originally at rest at theta equals 0. When the 2-gram bullet strikes and becomes embedded in it, it is observed that the block swings upward to a maximum angle of 6 degrees estimate the speed of the bullet. Okay, so in this case, first of all, if you try to go through this, you see that it's not very straightforward to identify which concept is to be applied. But if you think of it in terms of the different events happening in this case, one event is the bullet striking the block and getting embedded. And then the second event, which is now the embedded bullet and the block are going to swing by an angle, then you can see that it is basically two ideas. First is A is bullet getting embedded. Okay, what's that going to do is it's going to transfer the momentum of the bullet to the block, right? And if there's a transfer, and if you know that the velocity of the block with the bullet, then you should be able to find the angle it swings. So in this case, if we can find the velocity, the combined velocity of the block and the bullet, then we should be able to use that to solve part 2. And part B is bullet plus block swinging by 6 degrees. Okay, so for part A, what's the principle you use to solve for velocity of the block and bullet? Impulse momentum. So it's clearly not position as a function of displacement, right? It's not 2. It's actually 3b. If you look at the system of bullet and block, so for A you need to use conservation of momentum. So now the bullet gets embedded, and the system has a velocity, which is, by the way, is an unknown, and that velocity is going to cause the whole thing to move by 6 degrees. And so now you know the velocity when it's at 0 degrees, and you know that at 6 degrees it's going to come at rest, because it's like a pendulum. So if you know the velocity at one instant, and you want to find and you know the displacement and also the velocity at another instant, then it is basically belongs to number 2, which is, in this case, it's going to be 2a, because there are only conservative forces. So you got to use conservation of energy. Okay, and really the way you solve it is, if you're given the velocity of the bullet, then you solve it A to B. But since you're asked to find the velocity of the bullet, you're going to solve it backwards. So you're going to start with B and then proceed to get A. Okay, so I'll post the solutions from the book. It's a question from 15. Your exam is on Friday. Again, there'll be random seating and 3 questions, 50 points, 55 minutes.
How many questions are 3?
One question. I was looking the online test review. The first one was like the R dot and eta dot, and it said something.